Imagine looking at the night sky tonight and suddenly realizing the moon has completely disappeared. Not eclipsed, not hidden behind clouds. The moon is simply gone, as if it never existed. At first, Earth would look almost normal. But beneath that calm surface, important changes would already be beginning. The first thing you would notice is the darkness. Without moonlight, nights would become dramatically darker.
Millions of people would look upward, wondering why the familiar object that has guided humanity for millennia was suddenly missing.
But the darkness would only be the beginning. The moon affects Earth in ways most people rarely think about.
Astronomers would immediately confirm something extraordinary. Earth's natural satellite was no longer anywhere in the sky.
And that raises a much bigger question. What happens to Earth when its moon is suddenly removed? The oceans would change, wildlife would respond, and eventually, even Earth's long-term stability could be affected. So let's follow the timeline, from the first night to consequences that could unfold over thousands of years. In the first hours, Earth itself would not suddenly stop spinning, explode, or fall apart.
Instead, the most obvious immediate change would be the night sky becoming far darker.
Without reflected moonlight washing out the sky, countless faint stars would become much easier to see. Remote deserts and mountains would reveal an astonishingly bright Milky Way against an otherwise much darker landscape.
For astronomers, darker skies could actually make some observations easier, especially far from artificial city lights.
But for wildlife, darkness is not simply a beautiful view. Lunar light can act as an important environmental signal. Some animals use lunar light and cycles to influence navigation, feeding, reproduction, and movement. Different species would react differently, because not every animal depends on the moon in exactly the same way. But darkness is only one part of the story. The biggest immediate physical effect would involve our oceans. The moon's gravity is one of the main forces driving Earth's ocean tides. So if the moon vanished, its gravitational contribution to the tides would disappear too. But the tides would not disappear completely, because the sun also exerts gravitational influence on Earth's oceans. Instead, Earth would be left with much weaker tides, dominated by the sun's gravitational influence.
That would gradually change the rhythm of many coastal environments around the planet.
Tidal pools, wetlands, beaches, and shallow marine habitats all depend on changing water levels. Reducing the strength of those cycles could reshape the conditions many coastal organisms have adapted to.
Some marine species would face new environmental conditions, while others might eventually adapt.
For example, some sea turtles use visual cues from the night sky while navigating toward the ocean.
The timing and strength of tidal exposure would also change the feeding opportunities available to coastal animals.
Over longer periods, these repeated changes could gradually reshape entire coastal ecosystems.
The oceans would still move, but their familiar lunar rhythm would be permanently altered.
And the oceans are connected to something even bigger: the countless organisms that depend on these cycles. Across forests, deserts, oceans, and coastlines, animals would suddenly experience a different nighttime environment. Some nocturnal creatures could benefit from darkness, while others could lose useful lunar cues. Species that use moonlight as a navigation signal could face one of the most immediate challenges.
Migratory animals may also encounter changed environmental signals, although their responses would vary by species.
Even underwater ecosystems could experience changes because lunar cycles influence many marine behaviors.
Predators and prey could also experience a new balance between darkness, visibility, and activity.
But nature would not simply collapse. Life is remarkably adaptable, and many species could adjust over time.
Some animals might change when they feed, hunt, travel, or reproduce.
Scientists would spend years studying which species adapted and which struggled with the new conditions. Over generations, natural selection could favor behaviors better suited to a permanently moonless world. And while these ecological changes could be significant, Earth would still continue rotating normally. That brings us to one of the biggest misconceptions about a moonless Earth.
Earth would not suddenly stop spinning just because the moon disappeared.
Its rotation would continue because Earth already has enormous angular momentum. Earth would also continue orbiting the Sun, following almost the same path around our star.
Days and nights would continue, seasons would continue, and life would not suddenly experience planetary chaos.
The more important changes would happen on much longer timescales.
The moon plays an important role in stabilizing Earth's axial orientation over geological timescales.
Without the moon's stabilizing influence, Earth's axis could become more susceptible to long-term variations.
But this would not mean Earth suddenly tips sideways or becomes unstable tomorrow.
Any major changes in axial orientation would develop over extremely long periods.
We are talking about astronomical and geological timescales, not hours, days, or even a few years.
So the disappearance of the moon would not instantly make Earth uninhabitable. Instead, it would remove one of the natural influences that has shaped Earth's long-term history.
The planet would continue its journey around the Sun, but its long-term dynamics would be different. And that difference becomes more interesting when we imagine centuries and thousands of years passing. Coastlines, ecosystems, animal behavior, and astronomical conditions could all gradually respond to the missing moon. But there is another change that would affect almost everyone on Earth every single night. Our nights would become some of the darkest, naturally illuminated skies humans have ever experienced. Far from city lights, the stars would appear dramatically more prominent without the moon washing out the sky. Astronomers could gain darker natural observing conditions, especially in remote locations. For ordinary people, however, the psychological and cultural change could be enormous. The moon has shaped calendars, stories, navigation, art, religion, and human culture for thousands of years. Imagine generations growing up without ever seeing a full moon rise above the horizon. The night would look more beautiful in some places, yet strangely unfamiliar almost everywhere. And those visual changes would happen alongside the biological and tidal changes already unfolding.
Slowly, Earth would become a planet that looked and behaved differently from the world we know today. Not destroyed overnight, but gradually transformed by the absence of one familiar celestial companion. And that is perhaps the strangest part. Earth could remain alive, The moon may look like a distant rock, but its relationship with Earth is far more important than it appears. So would the disappearance of the moon destroy Earth? Surprisingly, no. Earth would keep spinning. The oceans would keep moving. Life would continue.
But the tides would be weaker. Lunar-dependent ecosystems would face new conditions, and nights would become much darker. Across ecosystems, species would have to respond to a world that suddenly lost its lunar rhythm. Over geological timescales, the loss of the moon's stabilizing influence could also matter for Earth's axial behavior.
Yet the planet would remain a living world, orbiting the sun beneath an extraordinarily dark sky.
The moon would be gone, but its absence would leave fingerprints across Earth for generations. A world without the moon would not be the end of Earth. It would be a very different Earth.
So, a moonless Earth wouldn't instantly become a dead world.
But it would become a very different one.
The oceans would change, wildlife would adapt, and our nights would become dramatically darker.
But our moon isn't the only thing that could have changed the history of life on Earth. What if the asteroid that killed the dinosaurs had simply missed Earth? What if the asteroid that killed the dinosaurs had simply missed Earth?
What if dinosaurs never went extinct? And what would Earth look like today? Find out next on CurioVerse.
If you enjoyed this journey, hit the like button. It really helps CurioVerse grow. What should we explore next? Comment below and watch the next CurioVerse to discover what if dinosaurs never went extinct.
Subscribe to CurioVerse and turn on notifications for more mind-blowing what-if science.